Hello everybody, welcome to your quick little lesson tonight. It's going to be short, but it's important that you write these couple of definitions down so that you have them and can refer back to them whenever we need them for the next activities the next couple of days. So we're in section 5-3. We're talking about rate of change and slope. Okay, these are two words you may have heard before. Some of you may already know what they mean, but if you don't, we're going to talk about it now and then really explore it when you come to class. So rate of change, you'll definitely want to write this down. Rate of change is the change in the dependent variable over the change in the independent variable. Dependent variable is which variable? The y. So another way of me saying this is the change in y over the change in x. Independent variable is always our x, so we should know that. Okay, so if I find the rate of change between two things, I'm finding how much did it change, did the values change in the y direction, how much did they change in the x direction, and then I divide those two values to get my rate. Now rates can be different. If you're given a set of data, I could have different rates of change among all of my data points. However, I have a real special case where my rate of change is constant. Constant means it doesn't change. So if my rate of change stays the same for all of my data values, I get something that is called slope. Slope is the constant rate of change of a line. Okay, my rates of change do not change between the data points in this special case. So if I look at this graph here of my line, I want to find the rate of change between 2 points. Okay, now it's really important that we write all of this down on this slide. The first thing is that we write down what rise means. Rise is like the change in the y direction. It's how the difference between y values from any 2 points on a line or any two yeah, I guess when we talk about rise, we are talking about a graph, not a table. Then I have my run, which is the difference in x value. So think about rise. If I ask you to rise out of your chair, you have to get up. So we're talking about the vertical change there, the change in the y direction. Versus if I ask you to run to the door, you're going horizontally. We're not running by bouncing up and down. We run horizontally. So the run is the difference in the x values between 2 points on a line. Now slope, again, is simply the ratio of the rise to the run. So I have slope equals rise over run. Another way of saying rise is change in y. Another way of saying run is change in x. Okay, so when I look at my graph, back to the graph here, if I want to find the slope of this line, I need to find the rise over the run. So I'm going to start by looking at this point right here that I just made blue. And I want to find how much do I rise to get from this blue point to my next point, which is right there. So I'm going to count. I rise up 1, 2, 3. So my rise is equal to 3. And now I'm going to count how much I run. When I run to the right, 1, 2, that is a positive value. Going up is always going to give you a positive value. Going to the right is always going to give you a positive value. And if I look at this by definition, my rate of change, 3 over 2, has to be the same for all 2 points on that line. So I can continue this process by going up 1. If I'm trying to get to this point, from here to here, I can count how much I rise. 1, 2, 3. And I run 2. So that slope is 3 over 2. Same thing, if I go from, let's see, this yellow point to this point, my rate of change, my slope, should be exactly the same, 3 over 2. Let's check it. 1, 2, 3 over 2. So that slope is 3 over 2. It's the rise. I had to go up 3 to get there, and then I had to go right 2. Now, some of you may have asked, what if I started here at this black dot and I went to this point? Can I go the other way? And the answer is yes. However, when I go down 1, 2, 3, that is equivalent to negative. So I went down negative 3. Now when I go to the left, that's also a negative value. So that would be going left, -2. Now, a negative divided by a negative is a positive, so I end up with the exact same slope of 3 over 2 as I did whenever I started here and went here. Okay, so it doesn't matter which way you go, as long as you go between any 2 points, as long as you remember that when I go up, that's a positive value. If I go down, that's a negative. If I go to the right, that's going to be a positive value. And if I go left, that's negative. As long as you do that correctly, you should be fine. That is all we have for today. We're going to take this knowledge and apply it in a couple different situations here in the next couple days. So make sure you've written all this down, and I'll see you tomorrow.